Hello, ladies and gentlemen, and welcome back. In this video, we're up to question number 4 on our 2011 Euclid, so thank you for joining me, and let's dive in and take a look, shall we? Alright, so we got two parts here, light bulb and a written, A and B. For A part, 3 different numbers are chosen at random from the set 1, 2, 3, 4, 5. The numbers are arranged in increasing order. What is the probability that the resulting sequence is an arithmetic sequence? So an arithmetic sequence is one where you just sort of start with a number. Their example starts with 3, and then you just keep adding on a constant, in this case for their example 2, to get the next number. So 3 plus 2 is 5, then plus 2 again is 7, plus 2 is 9, and 11, and so on. So that's what an arithmetic sequence is. And you do need at least 3 numbers to make an arithmetic sequence. And so they just want to know, okay, 3 numbers are selected here at random. What are the chances that you get an arithmetic sequence? So how do you handle a probability question? Well, for most of the contest questions you'll encounter, probability is just the number of outcomes you want divided by the number of outcomes that are possible. So in this case, we're going to count the number of ways I can make an arithmetic sequence, and then count the number of ways that I can just pick 3 numbers, period. So you can do either one. I mean, it's a light bulb question, so you don't actually have to show any work, but we will show a little bit of work. Let's figure out the number of possible arithmetic sequences we can have. So we're picking numbers out of 1, 2, 3, 4, and 5. As soon as I pick 2 numbers, that should determine the third number, because the difference between the first 2 numbers should then give me the last number. So, for example, what could I do? Well, I could start my sequence with 1, and then, well, what possible other numbers could I have? I could have 1, 2, 1, 3, 1, 4. I'm going to assume that the second number I pick is the smallest number, and then use that to determine my third number. So, for example, 1, 2, well, the difference there is 1. So, how do you go from 1 to 2? You add a 1. So, I should go from 2 to the next number by adding 1 again. So, I should get a 3. How do you go from 1 to 3? You add 2, so add 2 again, you'll get 5. 1 to 4, you add 3, you get add 3 again, you get 7, but of course 7 is not one of these numbers, so that doesn't count. 1, 5, then you'd need to have 9 as your third number, that's also not in the set. So this is it for arithmetic sequences that can start with 1. How about starting with 2? So if 2 is the smallest number, we could have 2, 3, we could have 2, 4, we could have 2, 5. Now, here we get a 4, you'd need a 6, and you'd need an 8. These ones will not be ones that you can actually pick. So the only arithmetic sequence where 2 is the smallest number is 2, 3, 4. How about 3? Now, this is the last one we need to consider, because we need 3 terms. If 3 is the smallest, you'll have to pick 4 and 5. And indeed, that works. If you had 3 and 5, then you'd need 7. That wouldn't work. Okay, similarly, if you tried 4 and 5, you'd need 6. 6 is not one of the numbers that are possible. So I'm seeing 4 different ways to make an arithmetic sequence. Okay? But now, how many ways are there to just pick 3 numbers? Now, you could do some work like say, okay, well, I could pick 1, 2, and then 3. I could pick 1, 2, 4, 1, 2, 5. And this isn't bad per se. And there's all the ways you can pick things that have the number 1. Now let's try without the number 1. So it's not a problem, but if you aren't organized, you might find that you'll miss a possibility. And that wouldn't be so good. So in total, you can get 10. So it'll be 4 out of 10. Now another way to see that, if you're familiar with combinatorics, we've got 5 numbers in my set. I want to choose 3 of them, so we can use this notation, 5 choose 3. This is 5 factorial over 3 factorial, and then the other number is 5 minus 3, which will be 2 factorial. And so 5 factorial, that's just 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. 5 minus 3 is 2, so we need 2 factorial in here. Well, that's 2 times 1. And we can just start canceling out. So it'll be 20 over 2, which again is 10. And that's sort of another way. Now it's question number 4. Can you do question 4 without that? Of course, you can just list things out. But if you know things like choose notation, if you know combinatorics, if you know binomial coefficients, you might know 5 choose 3 is 10 and be able to do that really quickly. Okay. So our probability is going to be 4 out of 10. We're not going to leave it like that. We'll simplify to 2 out of 5. Give a nice little reduced fraction. So 2 out of every 5 times that I pick a random triple, we should get an arithmetic sequence. And we can see there they are. All right. And you could have, incidentally, figured out your number of possible outcomes. If you were going to list, then you could say, okay, out of these, which ones are arithmetic sequence, and gotten the 4 out of 10. That would have been fine as well. Remember, it's a light bulb. You don't have to show your work. Okay, so what do we got? 4b. In the diagram, ABCD is a quadrilateral. AB, BC, and CD are all length 6. We got a 90 degree here and a 60 degree here, and they just want to know what's the length AD. Okay, I can think of probably 2 ways to go about doing this question. The 60 here makes me think, oh, I'd really like a 30, 60, 90 right angle triangle. And the reason I like those is because, oh, I already went over. Yeah. The reason I like those is they're quite common on contests. And if you know one side, you can figure out the others. They have very nice ratios, 1 to root 3 to 2. Okay? So I might say, all right, well, we have a 60 down here. Let's drop a little perpendicular. So now you got the makings of sort of a rectangle. In fact, we could even drop a perpendicular down here. Remember, we want this length here. But with a 30, 60, 90 triangle and with 6 on the hypotenuse, I know that if I divide by divide 6 by 2, I should get the side opposite the 30 degrees. So that should be 3. And if I multiply the side opposite the 30 degrees by root 3, I should get the other side across from the 60. So we got 3, we got root 3. Now I know that this whole distance here was 6. This whole length was 6. So I get a 3 here as well. But this is a rectangle, so I get 3 root 3 here. I get 3 here. What's this distance right here? Well, or this length right here. It'll be 6, because the total side was 6, minus 3 root 3. And now I've got a nice little right angle triangle where AD, what I'm looking for, is the hypotenuse. So it's a written question, so you might want to say, well, drop point E perpendicular and point F perpendicular. You know, explain to whoever's marking your particular setup, and then say, okay, well, I know should be C. CDE is a right angle triangle with 30, 60, 90, and then you get the 3, the root 3. Here's a rectangle, and so on. So basically, what I said verbally, you want to write down. Do I have the? I do have the numberings, right? So C down here, B here. And then you could say by Pythagoras, AD squared is DF squared plus AF squared. So that'll be 3 squared plus 6 minus 3 root 3 squared. I'm going to avoid the calculator for a moment if I can. We'll get 9 plus 36 minus 36 root 3. 3 root 3 squared should be 27. So we'll get 72 minus 36 root 3. And that's AD squared. So AD would be the square root of 72 minus 36 root 3. Take out a factor of 36. You got 2 minus root 3. 6 root 2 minus root 3. I'm sure there's a nice expression for that. Actually, I'm gonna grab my calculator and see if I can recognize 2 minus square root 3 about 0.27. Okay, what's the square root of that? 0.5176. That does not particularly ring any bells. Let me see if doing the reciprocal, that doesn't help either. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Oh, that's a shame, because I think I'm going to have to leave my answer like this, 6 root square root of 2 minus root 3. Now, you want to leave your answers as exact as possible. I'm sort of upset that there isn't a nice expression for that. At least not one that I can see. Anyway. 2 and root 3, if I square both of those, I get 4 minus 3 is 1. There might be a way. There might be a way to do this. Anyways, I want to explore the other way of doing this. Maybe that'll give a nicer answer. So another way I can sort of see to do this. Got this 60-degree here. We got this right angle here. The other thing that sort of popped into my mind is we've got sort of the makings of a nice isosceles right angle triangle. We got A, D, C, B. If I connect AC together, well, it's isosceles right angle, so you're going to have a 45 here and a 45 here. And I can, by Pythagoras or trigonometry or just knowing isosceles right angle triangles, we can see AC is going to be 6 root 2. And we also have a 6 over here. This whole angle was 60. We've just gotten rid of 45 of it. So what's left over? 15 degrees. So we could use the cosine law to figure out AD. So you could say, by cosine law, AD squared is what? Well, it's the other sides squared added up minus twice the product of the other sides and then the cosine of your angle, in this case 15 degrees. So that'll be 36 plus 72 minus 72 root 2 and then cosine 15 degrees. You could grab your calculator if you want. I'm going to see if I can't remember cosine 15 degrees off the top of my head, but I do know cosine of twice an angle is, there's an expression. It's cos squared theta minus sine squared theta. But I can change that to 2. So add on a cosine theta and add on a sine theta. So I can make it 2 cos squared theta minus 1. Okay, if I doubt that really quickly, pi by 2, cosine of 2 times pi by 2 would be cosine of pi, which would be minus 1. And that'd be 2 times 0 minus... Okay, so yeah, I got it right. It comes up in my second term calculus course, but for some reason I never remember these double angle formulas as quickly as I should. But I always if I'm a little nervous, I always double check with some known angle measurements. Anyway, so if that's true, then cosine of 30 degrees, twice 15, is 2 times cos 15 degrees squared, minus 1. Cosine of 30 degrees is root 3 over 2. Add 1 to both sides, divide by 2, and we'll get cos squared 15 degrees. So we'll get root 3 plus 2 over 4, and we want to square root that, and that should be cos 15 degrees. So that'll be square root of 2 plus root 3 all over 2. And again, I'm pretty sure there's a nicer expression for this. I can't, off the top of my head, think of what it should be for 2 plus root 3. But maybe at least I can recognize this a bit more if I plug it on a calculator. 2 plus root 3. 3.73, and if I want to square root that, 1.93 again. Now, wasn't that 1 over... Yeah, that was 1 over the square root of 2 minus root 3, which I don't think is any help right there. But I can take this, I can plug it into my expression. So what we had, 36 plus 72 is 108. So AD squared is 108 minus 72 root 2 square root of 2 plus root 3 over 2. Okay. Take out a factor of 36 here. We'll get 3 minus square root of 2 plus root 3 over root 2. So square rooting AD is 6, and then square root of this expression, which is not particularly helpful. But I'm confident it can be turned into 2 minus root 3 somehow. What would I do to turn this into 2 minus root 3? Actually, let's double check with a calculator that it is 2 minus root 3 before I start doing something wrong. 2 plus root 3, square root that, divide it by the square root of 2, so 1.366, and then add 3. Something's... Oh, when I took out a factor of 36, I should have a 2 here. Oh, yeah, so this should be a 2 here, but I'm looking at if you subtract 3, we get 0.2679. Yeah, so it's the same thing. But what I'd really prefer it if it was like, if this expression turned out to be 3 root 3 minus 2 or something like that. Unfortunately, I can't think of a way to do it. Now, this is a perfectly fine answer. Right? No one's going to be upset with that answer because it is exact and it's fairly simple, and I can't immediately see a way to simplify it. So it's a reasonable guess that there's not a nice way to do it. Reasonable guess. I have been doing contests for a while. If you want to move on to the next question, question 5, you're more than welcome to do so. I'm going to play around with this for another 5 minutes, see if I can find something to do with it. But as far as I'm concerned, and as far as you should be concerned, question 4 is done. But I want to play around with this just a little bit more. Okay. 2 plus root 3. I want to square root that. Oh, sorry, 2 minus root 3. What could we try to do here? Well, I suppose if I recognized it as something like this, we'd be all set. So if I can write 2 minus root 3 as a squared minus 2ab plus b squared, then I'd have a minus b squared and then just square root it. So matching things up, I need a squared plus b squared to be equal to 2, and I need minus 2ab to equal minus root 3. So 2ab needs to be root 3, ab needs to be root 3 over 2. Okay. Now, if I add 2 root 3 to both sides, I should get 2 plus root 3 is a squared plus 2ab plus b squared. But that shouldn't help because a squared plus b squared will still just end up being 2, and I don't have a nice way to deal with that. I suppose we can let b be root 3 over 2a. And so b squared would be 3 over 4a squared. And so 2 is a squared plus 3 over 4a squared. So multiply by 4a squared on both sides. You'll get 8a squared is 4a to the 4 plus 3. Quadratic formula. This, I don't think this is going to factor nicely because of that 3 there. Well, maybe. 2a squared minus 3. That had to be minus for both of them. 2 times minus 1. Yeah, actually, no, that would work. So a squared is either 1/2, or a squared is 3 over 2, and so b squared would then be the other one. So we get a plus b. Actually, we need a minus b because that's the square root there. So square root 2 minus root 3 should be equal to a minus b. We'll take a to be the bigger one. So root 3 over root 2 minus 1 over root 2, or root 3 minus 1 over root 2. Now, we can double check with our calculator here. Root 3 minus 1 divide by square root of 2. No, I'm a little off on something there. But that does give me the a times b that I want. Right, it's root 3 over 2. Yeah, that would be fine. Did I not factor this properly? I let a squared be 1/2. 0.5 times 0.5 times 4 is 1. Minus 8 times 0.5 is negative 3 plus 3. No. I factored it just fine. So why isn't my a minus b working? Oh, wait, no. 2 minus root 3, and then I have to square root it. Oh, no, okay, we are right. Yeah. So root 3 minus 1 over 2, which means I can actually simplify my answer a bit more. So 6 root 3 minus 1 over root 2. And so 6, get rid of a factor of root 2 there, so we'll get 3 root 2 times root 3 minus 1. So a more precise answer would be 3 root 6 minus 3 root 2. Or I guess you could say 3 times root 6 minus root 2. Whatever you want. Okay? And actually, now that I'm looking at it, I think cosine 15 is root 6 minus root 2 over 4, something like that. I'm not going to check that, but I did what I wanted to do. I got a nicer answer, not with a square root inside a square root. That always looks unpleasant to me. Anyways, if you stuck around, there you go. We did it. If you didn't, well, you're not watching this and you stopped a while ago because we did get a nice, decent answer for AD. Okay, and that was the last part, right? Yeah, that was B part. Okay, so up next, we're going to be looking at question number 5. Hope to see you for that in the next video. Take care.